Oh, good morning, good afternoon, and good evening, depending on where you're joining us from. My name is Kim Everhart. I'm a member of the marketing team here at Percona, and I want to thank you for taking some time out of your day to join us. I have Ibrar Ahmed here. He is a senior engineer at Percona, and he's going to go over this webinar on multi-primary replication solutions for PostgreSQL. I don't know if I said that right. PostgreSQL, PostgreSQL. I will let Ibrar, he will say it properly when he comes on, I promise. So before I turn it over to him, I'm going to just do a few housekeeping items for everybody. So first, I just want to check sound. So you guys have a little hand icon. If you can hear me, can you put your hand up? Awesome. I see hands going up. That's a good sign. Okay, I'm going to drop those down, and then I'm going to ask Ibrar to say a few words too, so we can test his sound. Okay.
Hello, everybody.
Perfect.
So hopefully everybody can listen me.
Yes, so if you hear Ibrar, can you please raise your hand? Okay, it looks like that's good. All right, so we've got our sound going. So second thing before we get started is sight. Can everybody see the slide deck on the screen? Hands up, please. Okay, awesome. I see hands going up, so I think we're good there. So then just a few other items before I turn it over, which is everybody's muted, but we totally welcome questions. So if you have any questions, feel free to drop them in the question window below, and we'll save those for the end of the presentation. This is being recorded. So if you want to share it with a colleague, or if you have to drop out early, you will get a copy via email within the next 24 hours. And I believe that is the biggest part for me. So Ibrar, if you're ready, I'd love to turn it over to you.
Thank you. So, my name is Ibrar Ahmed, and today's webinar is about multi-primary replication solution for PostgreSQL. So, let me clear the confusion that Kim has that it's PostgreSQL. You can call it Postgres or PostgreSQL.
Most people or PostgreSQL. Okay, I'm good.
So actually, the most of the people mispronounce it's a PostgreSQL. Postgre. It's not Postgre. It's PostgreSQL or Postgres. So these are the two words used for the PostgreSQL. So usually I use PostgreSQL. So it's people's choice. They choose Postgres or PostgreSQL. So before starting this presentation, let me introduce myself. My name is Ibrar Ahmed. I am Senior Database Architect at Percona. I have more than 14 years of PostgreSQL design and development experience. I have multiple books authored on PostgreSQL. So today's topic is multi-primary replication solution for PostgreSQL. So before this, another disclaimer that usually the naming conversion has been changed because of some incidents happen. So we are not talking about that names again. So we change it to multi-primary and multi-replica. Like it's one primary server and the replica server. So we will not use another words like master and slave. We will not use that words anymore. If any of this word used by me accidentally, so pardon me about that. So because it was a habit to saying that, because the previously we used that words. So pardon me if accidentally I use these words. I try to remove all of these words from my slides and use primary or replica here. But in one or two slides where I have picked some other companies' pictures about the replication solution, they use the same word. So pardon me if you see that word in their picture. So I did not, I have not done that intentionally. But it's because their picture, I cannot change that picture. So pardon me about that too. So let's begin. Replication. So before going to the multi-primary replication, or replication, we would need to study what is the replication. So before this, I have 1 or 2 slides about the replication. So by book, the definition of replication is replication in computing involves sharing information so as to ensure consistency between redundant resources such as software or hardware component to improve reliability, fault tolerance, and accessibility. It's a bit complex kind of a definition because it's a bookish definition of replication. I picked it from the Wikipedia. So link is there. But for the clarity, I have a very simple definition of replication. Database replication replicates the data on other server and store it on more than one node. So you have a data in one machine and you want to have that data, same data set to other node. So, and this process is called replication. And the main server where you have the information called primary, and where you want to put your data, replicate your data, it's called replica. So data is transferred from one node, which is called primary, to another node, which is called replica, and an exact copy of data is made. So it's exact copy of data is made. So there is some exception that I will tell you where you don't need to replicate the whole data, where you want to replicate a part of the data. So it's exception, we will study later. Why data replication? Data replication is used to improve the data reliability, because in high availability system, you need to ensure your data is available all the time. So if you have your data in one place, I mean that place is crashed, the server crash, and anything happened to that server, so you cannot ensure the high availability because you don't have multiple copies of that data. So data replication is used to improve data availability, because if you have a data on multiple places, then it's really easy to provide an high availability, because if 1, 2, 3 sites crash, you still have some data somewhere to provide the service to the user. And that's the exception, that a full database instance can be replicated. That if you have a complete data set and you want to replicate the whole data as it is and make another copy of their database, you can do that. And or you have an option to replicate your frequently used object, like your table. You have 10 or 15 tables and you don't want to replicate each and every table, because you only replicate some table, 1 or 2 table. You can do that. It's not compulsory to replicate the whole data. You can do that, whatever your choice, but whatever you require. As replication provides the multiple consistent copies of the database, it's not only provide high availability but also improve the performance. That's the interesting thing. Why? Because if you have a data on multiple places, then you can read from different places. Like in USA, if you have if you are in USA, that you have in one state, you have some servers, and then you have some server replicated in other states, and you only want to that state user can access their own server, and this and first state's user can access their own server. So there is no bottleneck because you have a multiple copies of database, so anybody can read that, which have authorized user definitely. So it's not only provide the high availability, but also it also improves the performance. So we will discuss it's a read performance only or write performance. When I'm talking about the read performance, it's it's the part of the replication. But when I said that it's the right performance, then we required multi-primary replication. So if in a single primary replication, you have one primary and multiple replicas. But in other case, in multi-primary, you have multiple primary. So you can write on primaries. So I will give you the definition of primary and replicas in next slides. So in single primary replication, you can only have a read performance, but in multi-primary, you can also have a write performance. But with some exception, definitely, we will study in next slides. So replication, I'm not talking about the replication as a journal, how Oracle will replicate, how MySQL will replicate. So I'm come to the directly to the point where how Postgres replicates its data. How many type of replication Postgres has. So in general, we divide replication in synchronous replication or in asynchronous replication. So the definition, synchronous replication means data is written to primary and replica simultaneously. Synchronous replication means now the first one, synchronous replication means data is written to primary and replica simultaneously is a general definition. Now come to the in terms of database. Synchronous replication means commit waits for write on the remote side. Right, when you have one replica and one primary, when primary you are writing on the primary, and when you issue a command commit, it will only return when that data is written to the replica and you get the acknowledgement, and then it will write to the, then its commits will return. So it will wait till remote side write that data. So synchronous replication is used in the high-end transaction environment with instant failover requirement because it's safe. Why it's safe? Because it ensures the consistency of data each and every time, because it will not commit the data unless it's written to the replicas. So you have a consistent copy every time without any lag. So it's used where you need a consistency on all the replicas and the primary. But you have to pay the cost. What cost? It's slow because it wait, because there is no lag in that. It's sure that the consistency. So that's why it's a bit slow other than that. So in asynchronous replication means data is written to primary first and then replicate to the replica. So in asynchronous, that when you issue a commit, it will commit that and that data is written to the replica. In the case of crash, data loss can occur, but asynchronous replication provide very little overhead. Therefore, it is acceptable in most cases. As I told you that in synchronous replication, the consistency of data is ensured. So if data crash, then that's mean it's not written to the replica nor the primary. But in asynchronous, if the crash happens, it's possible the data loss occurs. But it has a very little overhead on the server, so it's acceptable. But it's your choice. So you want asynchronous where you need a consistency, or you can afford to some loss in case of crash, but it will give you the better performance. It's up to you. it does not overburden the primary. As we said that it will only it commits and then be sent to the replica, and replica write that data. The failover from primary to secondary take a longer time than with the synchronous application. Definitely, because in synchronous application, we already ensured that data is written all across that. So failover is easy in synchronous than the asynchronous. The second division of replication is logical replication or physical replication. So as we say, the logical replication is a method of replicating data and object and their changes based upon their replication identity, usually a primary key. So it's a PostgreSQL documentation definition. Link is at the bottom of the slide. So the physical replication means the data move to the remote node as is in a binary format. So in a physical, I will elaborate that in a physical replication, data replicates from one node to another node as a binary format. No SQL other than that, just a binary format. Data is replicated from one location to another location. And usually it happens for the whole database and database cluster. But in logical replication, you can replicate your data, some part of the data, some objects to the remote side. As in the previous slide, I told you, you can replicate your database, your cluster as a whole, or you can replicate your data objects which frequently used. So for the logical application is used where you want to replicate your sum of your objects, some tables and so. Okay. But in a physical application, it's a binary format application, and this data is replicated from one node to another node in a binary format. Now, another type of segregation or type of replication is single primary replication or multi-primary replication. So what is the single primary replication? Single primary replication means data can be modified only on a single node. You have a one node which is called primary node, and you can have a multiple replicas. So one you can only write to the primary node. So when I'm said the primary node mean a node where you can read the data and you can write the data. So in that case, primary, you can only write the data on the primary node, which is a single primary node in a single primary replication. And this modification where you write to the primary, a single primary node, it's replicated to the other nodes, which is called replicas of that. And on that replicas, you can read the data from there. So you have one primary node and you have a replica. So you can write onto the primary node, you can read from the primary node, you can read from the replica, but you cannot write to the replica. So if you have an application where you want to write to the all the replicas, so what you have to do, you have to modify your application, or you have to write your application so to send all of your data to primary, and that primary routes that information to the replicas. So you have to write your application like send all the traffic to the primary. So it's your application can be a bit complex. The second type of replication is multi-primary replication. Here we have multiple primary nodes. We can have a replicas, we can have a multi-primary nodes. So suppose you have a two primary nodes, and In that case, you can write on both the nodes and you can read from the both the nodes. So in that case, there is no problem at that, because you can read from each node, you can write on the each node. So data is replicated between nodes, and update and insertion can be possible on a group of primary nodes. So the primary nodes can be written. You can write on that, you can insert on that, you can update on that, you can delete on that. In that case, there are multiple copies of data. Definitely, you have a multiple copies of data, because when you write on one primary node, it's replicated to the other primary nodes. And when you write to the other primary nodes, it again replicated to the other all primary nodes. The system is responsible for resolving any conflict that occurs between concurrent changes. So that's the biggest problem of multi-primary replication. Why? Because in that case, you are writing on two nodes, and its chances is there that you are writing on the same table. You are modifying on the same table row. So if one client modify on one primary node's tables specific row and the similar at the concurrent time at the same time, another client is updating the same table, same row, and another primary, then it has to be replicated. So which will go first and which will be adopted as a master copy of that? That is called conflict, and system is responsible to resolve the conflicts. So this is the biggest challenge. So what really the multi-primary replication solution do? They try to solve that. If they are unable to solve that problem, then they will give the priority to the user to set they take some advice from the users. So this happen, please fix this. So because this is a serious problem. So we will discuss how or which application are resolving conflicts or which are not. So we will learn in next slides. So we learn the type of replication, a different type of replication, and some definition of replication. But in this slide, for the next slide, we will only focus on multi-primary replication, because this webinar is all about multi-primary replication. I'm planning to do that some other webinar on a different replication solution, but this specifically webinar is on multi-primary replication solution for PostgreSQL. So this multi-primary replication. So here is, again, I just put that the same wording back in this slides too. So if you see, we have a node A, node B, node C, node D. We have for 4 nodes in this cluster. And you can see all these nodes are primary nodes. All these nodes are primary nodes. And data is replicated in between. You can see the arrows of replication. Data is replicated in every node. So every node is primary. So on the right side, you can see a computer where you can see that it's a client which can read and write to any of the replica, because these not replica, sorry, primary node, because all are the primary nodes. So these are 4 primary nodes. They are all replicating data to each other. So how many primary nodes you have, then it's more chances do you have a more conflicts, because the clients are modifying data onto the primaries. It has to be consistent on all the primaries. Then it's possible that the same rows affected many times, so more chances of conflicts will occur. So this is the main picture of the multi-primary replication. So what are the benefit of multi-primary replication? Suppose in case one primary fails, the other primary is there to serve the update and insert. It also it's a shaggy definition, because in replica there's a failover scenario. You can have that too, but that in the single primary, it's also possible that the replica can become a primary and it can serve that. But it has, the replica should become a primary to serve that. But here it's already primary is there to serve that. It's already there. In case of single primary, the failover should happen and the primary, the replica become the primary. But in multi-primary replication, there already primaries exist, so they can serve as the primary. They were primary, so they were serving that, so there is no problem at that time. Primary nodes located in several different locations, so chances of failure of all primary nodes are very minimal. Like you are updating on a different primary nodes, you are bursting on a different primary nodes. And if it's a different location, if one primary fails, there is no chance that the other all at once crash at the same time. So your update and insert will be served as previously. Data updates are possible on multiple servers, as this is the main definition of multi-primary. The data updates can happen on multiple servers. The application do not require to route the traffic on to only a single primary. Yes, because if an application wants to write the data, you can configure any of the primary node, the nearest primary node. You can configure that, and it will update that. So you don't need to write an application to redirect all your traffic to the one primary. The application can connect to the nearest primary node, no problem at all. So don't need to reroute the traffic, anything. These are the this is the benefit of multi-primary replication, but there are some problems. The main disadvantage of multi-primary replication is its complexity. To conceive the whole idea where you want a multi-primary replication solution is a bit complex. If you have 2, 3, 4 nodes, then it's not a problem. I'm talking about a big network. So you have to be very careful where you have a multi-primary, where you have a single primary replication solution. So it's a bit complex kind of a thing. You have to be very careful about it. The most of the time, people don't recommend to use multi-primary replication if it's not required. I'm talking about if you can solve the problem using single primary replication, it's recommended. But if it's not possible to achieve that with using single primary replication, then go to the multi-primary replication only. Don't try to oversmart and always use a multi-primary replication, because it will make things complex. Conflict resolution is very difficult because simultaneously write on multiple nodes are possible. Because it's even this is I told you that this is the benefit, that you can write on multiple nodes. This is the benefit. But again, if it's a benefit, it has also a problem, because when you are writing on a multiple nodes, chances are there you are modifying the same data on a different node. When you're doing that, then it's possible it conflicts, and it conflicts. The system should be very efficient and very intelligent to solve that conflicts. Otherwise, it will give you the error and you have to solve it yourself. Like the third point, sometimes manual intervention is required in case of conflict. as I told you, that if a system is not intelligent enough or confused which is the master copy of the data, a manual intervention is required. So user need to modify that. There is chances of data inconsistency because we're writing on the multiple server. The chances are there the data is inconsistent with some time, for some time. It will resolve later, but for some time. So if you want to read some detail about that I have a blog some time ago or 1 month ago. So link is there. You can go there and you can read the same slide in English format if you want to read it. It's a webinar time, and you can, if you want to read that, you can go to the blog and you can read that blog. So we have learned different type of replications: physical replication, logical replication, we read synchronous, asynchronous, single primary, multi-primary. So the interesting thing is synchronous, asynchronous, logical, physical, single replication, single primary replication. These are all available in PostgreSQL. These replication solutions available in PostgreSQL. Synchronous, asynchronous, logical, physical, single primary. The only one we have studied is not available is multi-primary replication solution. Postgres does not provide that solution. If I'm saying Postgres, that means the Postgres main core is not, the community is not supporting any multi-primary replication solution. So that's a big problem. So how you can overcome that problem? So I will discuss that the community has provided some concept which basically a logical replication. The different companies had used that capability of logical replication to have a multi-primary replication solution, and some companies has some kind of a different solution. So we will study how many solutions currently available and how and which companies are supporting them. So BDR, bidirectional replication. The second quadrant has a solution which is called BDR, bidirectional replication. So it's one of the finest implementation actually, as far as I know. I'm not biased about that. I'm not from second quadrant, but actually what I have studied that the BDR is the mostly used bidirectional or multi-primary replication solution. Enterprise DB has an XDB. So this I just categorize in a sequence. That one, the BDR is the first one, the XDB is the second one, the PostgreSQL XL, sorry, is the third one. Postgres XC, Postgres XC2 / is the same thing. On the fourth position, and then Ruby Rep is the fifth one, and Barbado is the sixth one. Maybe there are other some small solutions available, or maybe some big solution, but I'm not aware of that. I am aware of these solutions available for the multi-primary applications. So here is some kind of where is this first one? Actually, the BDR has a different version. So BDR3, let's suppose we have a BDR3. The company, second quadrant, I already told you, is it an open source? No. BDR3 is not an open source project. Language used in this is a C language. It's written in a C. Type is an extension, so it's not in a core. Failover, yes, it provides a failover. Synchronous or asynchronous, it's asynchronous. The thing is, it's supported Postgres version 12, which is the latest one. So its community is active, not community because it's not open source. Second quarter is actively developing that, yes, because this is the most important question. Because if some company is not working on that, if you find any bug or something, that then it will become problem, because you have it's a closed source and you find some bugs, so you can't do anything, cannot solve that problem. And if that company is not working on that, so you're stuck at that point. So that's the most important thing. Last column is the one of the most important, active or not. So you have to think about that, it's active or not. The second option is BDR2. It's actually an older version of BDR3, is from second quadrant, open source. Yes, it's an open source, language is C, typing extension, failover yes, async yes, and Postgres is supported version is Postgres 9.6. I'm not saying that it won't work on Postgres 11 or 12. I don't know about that, but it's documentation. What I have seen that said its supported version is Postgres 9.6. Maybe it work, or maybe it won't work after that. And it's, I have seen that they are actively also working on that too. Mostly about the bug fixes and something like that. So at least it is open source. If you already installed PDR2 and you find some problem and it's not active, but you have a source code, you can have somebody to fix that and you can run that. Third is XDB. It is developed by Enterprise DB. Is it open source? No, it's completely closed source. You won't able to see that what happened underneath. What is language is used? It's written in Java. It's a type is an application, in a separate application, Java application. Failover, they provide some kind of a failover solution with that. And supported version is PostgreSQL 12. And it's active. Yes, they are working on that. Now talking about the fifth one. Actually, I'm not talking about the fourth one. Let me come to the fourth one after the fifth one. Entity and Enterprise DB started a project to have a multi-primary replication and the load balancer and something kind of that, which is called PostgreSQL. And it was written in C, which is open source. Its community is there, and it's a PostgreSQL fork. They fork a PostgreSQL and implement all that feature in that. It provides some kind of a failover, but its community is, it's yes active. Some people are working, and its second version is XE2. So it's XE and XE2. It's also a fork. The fourth one is PostgreSQL. Actually, if we see PostgreSQL is a fork of PostgreSQL. Second quadrant took PostgreSQL, XE2, and they start supporting that and added some feature over that. So its supported version is PostgreSQL 10. RubyRep is open source project, is also an application, but the problem is it's not active. So it's up to you. It's open source. At least if you want to deploy that, then if you find some bug, you have to solve it yourself. Percona is from Endpoint Corporation. Is it open source? Written in Perl, is an application, and PostgreSQL supported version is PostgreSQL 12, which is the latest one. So again, this picture is from my blog. I written a month ago. So when I'm talking about the BDR, so I'm not talking about the BDR2 or BDR3. So I'm going to just think about the BDR as a whole. BDR is a multi-primary replication solution. This solution is developed by second quadrant, and it is one of the most elegant multi-primary solution to date, because I heard many companies are using that. It's a good one. Early version of post BDR are open source, but its later version is closed source. Like BDR2 is open source, but BDR3, which is the latest one, is a closed source. It's a asynchronous multi-primary logical replication. It's used the logical replication, or you can say it's based on the PostgreSQL logical decoding feature. So we already said there is a two type of replication: physical replication or logical. And logical replication is based on the logical decoding. So this replication is based on the logical decoding feature of PostgreSQL. It's exploit the logical decoding feature and have a bidirectional replication. Since BDR apply essentially replace the transactions on the other node, the replay operation can fail if there is a conflict between a transaction being applied and transaction that was committed on the receiving. So there is chances of conflict and it can fail. So from the problem perspective, this I have not found much problem other than that this is the closed source solution, latest one. Other than that, I recommend people to use that because it's a good one. Because it's used. Second quadrant is the company which actually contribute most of the replication solution to the community, and they use the logical decoding, which their own feature, and so this one is the recommended one. The second one is the XDB. Enterprise DB, one of the PostgreSQL company, developed its own bidirectional replication solution in Java called XDB. It's based on their own protocol because it's a closed source solution. No design information is known to the world. When I'm talking about the BDR2 is open source. BDR3 is not open source, it's closed source. But at least we know that BDR, what is the design internally of BDR2, and we can predict what can be in BDR3. But in XDB, we totally don't know about that, the design or internal detail of that. That's another drawback. First drawback is it's closed source. The second, we totally don't know about the design implementation of that. It's developed and maintained by Enterprise DB. Yes, XDB replication servers contain multiple executable programs. It's not based on the one program, it's a multiple executable program. This is a completely closed source proprietary software. Developed in Java. Maybe about that or not, but I heard that people complain about its performance, especially its fail over time. The user interface is available for configuring and maintaining the replication system. Another good thing is that it's interface and maintained by a big PostgreSQL company. These are the two good things. And sorry about that. I just click that. And the good thing that this is interface available and maintained by a big PostgreSQL company. The problem is the performance and the closed source. And if you are coming from the Oracle background and you want to have an open source, but it's not open source. It's closed source again. And here is in the right side, you can see the picture. And I adopted that picture from the EnterpriseDB sites. So pardon me, you can see some offensive word there, which is, I don't want to use that in my slide, but unfortunately I have to pick their solution. So I cannot have a right to change that in my slides. So pardon me. So Postgres XC and Postgres XC2. Postgres XC is developed by EnterpriseDB entity. It's a joint venture project. It's a multi-year joint venture project between EnterpriseDB and entity. It is a synchronous application solution. Postgres XC is an open source project. Provide a Postgres cluster solution which is write scalable, synchronous, symmetric, transparent. So it's not only a multi-primary replication solution. They're providing a write scalable, and it has many features. It become a very big project, and it was actually fork of PostgreSQL. So they changed the PostgreSQL code to behave like multi-primary replication. So that's required changing back. But Postgres is changing their code. Yeah, they have to change in the Postgres XC, but they fail to maintain that. So for many years, we have not seen any changes in Postgres XC. Fortunately, Huawei, another company, adopted that and start working on that. So we can see that EnterpriseDB entity is not currently working. Maybe they're working, but we have not seen development from them since many years. So Huawei is working on that. Some performance gain has been reported. I've seen some. Sorry about that. I have not mentioned some of the link, but I have seen some of the performance benefit using that. In case of OLAP, somebody did some kind of a benchmark on that and show the performance in case of OLAP queries, but not on in OLTP. But not suitable for, oh, sorry, it's not TPS. Sorry about that, it's typo, but not suitable for OLTP. It's not TPS. Pardon me. PostgreSQL. So what I told you that Postgres XC or XC2 is a fork of PostgreSQL, and they modified the PostgreSQL and make it a multi-primary replication solution. But PostgreSQL is a fork of PostgreSQL. So they fork PostgreSQL and make PostgreSQL, and currently supported by second quadrant. It is well behind community PostgreSQL. I told you it has one big problem. What is the problem? The problem is it's a fork. Actually, it's a fork of PostgreSQL. It is fork of XC, and XC is fork of PostgreSQL. The problem is if some bugs and features has been fixed in latest version of PostgreSQL, it has to be merged in that, and it's a big task to do that every year, I think, because if you do that on the major version, you have to do that every year. I'm not talking about the minor version changes. If they only do that major version changes, then they have to do that each and every year, which is a big effort. That's why it is well behind community PostgreSQL. So it's currently, I have seen, maybe it's back some days, I have seen that it is based on 10.6. So 11, 1 year, 12, 2 year, and 13. I can see that 13 because it's October. You can see a G of 13. So it's 2 or 3 major version behind the community PostgreSQL. As we know, it's based on PostgreSQL. It is very good when we are talking. So it's same because it's based on the same concept of PostgreSQL. It's there is a 2 typo here. Sorry about that. It's not TPS or TP, not TPS. Another replication solution is Ruby. Actually, I think what we have studied that the previous 4, one is the main one we have already studied. These are the smallest one. It is an asynchronous primary replication developed by Lemon. It claimed the easiest configuration, setup, and work across platform, including Windows. So it's the major benefit I can see that it works on Windows. It always operates on 2 servers, which are referred as left and right Ruby. Rep terminology automatically set up necessary trigger because these are the main item I have wrote that. Actually, I'm running out of time, so I cannot explain each and every one. So I'm just picking some. It has custom conflict resolution specifically by Ruby code snippet. So it has some kind of a replication, conflict resolution. But the problem with that, the project has not been active for the last 3 years in terms of development. So I don't recommend that to use that because if 3 years nobody was working on that, so if you stuck somewhere in that, so you will be nowhere. So I don't recommend to use that. Barcado is a trigger-based application solution developed by John Jason and Greg of Endpoint Corporation. Barcado solution has been around for almost 20 years. So you can see it's oldest one, and originally designed as a lazy asynchronous solution for eventually replicate all changes. It's a per daemon. It has its own conflict resolution policy. Actually, if somebody knows Perl, it is different as a difficult language actually. And its installation and configuration is complex. The another problem, which is the it breaks often and it's buggy. So if it's buggy and breaks often, so I also cannot recommend you to use that. So here it is. So I think we are done here, and you back today. We have 7 minutes left, so we can have some questions. So,
Okay, great. We did have some questions come through. So sometimes when I read these, they don't make a lot of sense to me. So if I need to repeat them, just let me know, okay? If it's unclear with what I'm saying. So does this mean that active clustered environment is analogous to synchronous replication, while an active passive cluster is akin to an asynchronous replication?
No, I don't understand the question. You can repeat it.
Okay, let me try. Okay, so is an active cluster environment synchronous replication, while an active passive cluster is asynchronous replication?
No, actually, I told you there's a 2 types. If you are talking about the active, actually use the same terminology that primary. I'm not talking about the passive because it's again will confuse the other audience. So use the normal terminology which I have written in that. It's a primary. The primary means where you can write and read, and replica means where you only can read. Okay. So if you have a primary, you can have asynchronous, you can have asynchronous. If you have a primary and you have a replica, then you can have asynchronous, you can have synchronous. It's not dependent that you have primary, you need to have a synchronous or asynchronous. It's not binding you to use that. These are two different things. You can use either of the combination.
Okay, hopefully that answers their questions. If not, feel free to pop in and just let me know if you have need further clarification. Okay, so how does Postgres handle lag for multi-primary replication? Is there a timeout or so if one of the primaries does not respond?
Postgres doesn't provide multi-primary replication. So that's the answer.
Ah, well, there you go.
Because
okay.
Postgres doesn't provide that.
Okay. Would you provide information comparing these different solutions based on their installation, configuration, complexity level?
I think I cannot explain right here. I think I can, if I can write it for him, they can reach me. I can explain that in an email or something like that. Because
okay.
if you, because it's timeless, it will take more time to discuss each and everything in that respect.
Okay. What I can do is I'll send you all these questions at the end, and then we can put together a blog answering
Yes,
them. And that way everybody has access to it. Okay. Given the advent of new replication solutions using Raft protocol like CockroachDB and Yugabyte, why would we want to deal with the complexity with replication setup and management?
Again, repeat it.
Okay. Given the advent of new replication solutions such as Raft protocol like CockroachDB and Yugabyte, why would we want to deal with the complexity of replication setup and management?
Yes, right. Actually, it's up to you that if it's already available, and nobody is enforcing to use that, because these are the solution available. You have to think about that you required it or not. Definitely, because everything does not suit for everyone. Everyone has its own choice. So because the community also think about that there is no need of multi-primary replication, because that's why Postgres core does not support that. But some customer specifically coming from Oracle are asking for that because they want to replace the rack. So they specifically who are coming from the Oracle background and they have application where they were using multi-primary replication, they ask companies to have that multi-primary replication. Otherwise, if you ask me, is multi-primary replication is good for your setup, I will not recommend that unless you really require that, because it will add complexity to your network.
Okay. How well do these multi-primary solutions cope with big transactions?
How? Actually, it happens if multi-primary replication for the big transaction, if it fails, specifically in case of synchronous or asynchronous, both cases, if it fails, it will roll back the transaction. It won't happen. There is chances because of the long transaction. Definitely it can fail, but if you have a big setup, won't fail. It's definitely, cannot say is in black and white what will happen, because if it's timeout at something like that, it will fail. It depends on network and your setup.
Okay, well, we are pretty much out of time. So what I'm going to do is send the questions that came through that we didn't get to answer and the ones that were answered over to Ibrar, and we'll put together a blog for you. You'll be able to find it on Percona.com on our blog, and it'll also include the recording. So thank you all for joining us today. Like I said, a copy of this should be coming to you via email, and then we'll get these questions answered as well. Thanks, Ibrar, for your time today, and thanks everyone for joining us. Have a great day.
Yep. Thank you. Bye.
All right, bye-bye.